Welcome to Earth Science, everybody. Let's talk topographic maps. This is going to be where we're going. So, as a very basic intro to get us going, if we were to take a hill like this, next to a lake, little island, all of that, how can we represent this hill on a two-dimensional piece of paper, a map, right? I mean, if you go there, you look at it, you can see that it's a big hill, right? So, what this does is it tries to visualize, hey, if you started at the shoreline here and you started hiking uphill, maybe you're at an elevation right here of 50 feet above sea level. I guess this is in the ocean, right? Because these increments make that zero. So the shoreline is 0 feet in elevation above sea level. If you start hiking, you get to 50, you get to 100, you get to 150, and so on, right? Another interesting question we'll get to is where is it maybe steeper in other places? Steeper here, gentler here. What's the deal? So what does it look like when we represent that on a map? Maybe it's like this, where now looking down on the top, you see the ring for 400. Well, there's the ring for 400. 350, 300, and so on. Now, of course, this isn't really actually printed on any hills anywhere. It's up to us to figure out how to translate that three-dimensional land surface in our head to a two-dimensional map, or vice versa. Look at a two-dimensional map and see what the land surface might look like. Okay? So here's a picture of my son. This was right at the beginning of COVID, like that spring. And you can see that this is right after the bath, after I took him riding his little plastic tricycle down the hill in front of our house, which he decided to try to go faster than he's ever gone before, and then tried to use his feet to stop and went face first onto the asphalt of my road. So let's say, what kind of dad is this? Who would do this to their kids? Let's figure out what the deal was with this hill and measure it. How steep was it? Because we got to get to a point where we can like mathematically define how bad of a dad I am, right? How like we have to mathematically define how steep a hill is. We should turn this into numbers. This is the road right here. And if you're starting to figure out what topographic maps are about, these lines are increasing elevation, going up to a hilltop over here. He rode from this intersection down the hill a little bit. We're going to figure it out exactly, mathematically, right now in this video. You won't have to do it yet, but you'll be doing them soon. So let's start to wrap our head around what numbers would go with a steep hill. How steep is this? Where Silas smashed his face. So here it is. This is software on the internet that draws profiles automatically. Now I'm going to just throw it at you today. We're going to be doing this very precisely with pencil and paper. This is going to be a non-Chromebook thing when it comes time to do it. Drawing these profiles. So first, let's define profile. What is a profile? For you to do a profile view of me in art class, I'd have to turn sideways to the camera and you draw like that side view, like what you see on a quarter, maybe? That the side view of the president's face. What does the side view of this hill look like? I mean, this map gives us some idea if you can read topographic maps, but what this kind of cool website does, if I start a line here, I promise it's a thing. All right, there we go. If I start a line here and go over to there, what this is going to do, it takes a minute to do it, is it draws out the side view of this hill. So if you were to come to this road and look at it, like standing over here where my mouse cursor is and looking up at it, this is what you would see. The hill decreases as you go down here, and it gets down to a little river valley right there, and then comes back up over on that side. In fact, we could change it to, there we go. This will make the river stand out a little bit. A little tiny creek that runs through there. Okay. So here's what he did. He started up here, and I don't imagine he made it very far. I'm going to wait until this little number right here clicks over to a tenth of a mile, which is, that's actually probably about as far as you want, maybe a little less. So it says, if you look at these numbers right by my mouse cursor, it went down in red. It went down by 11.1 feet. The elevation right here at this spot is 353.7. Up where he started, 364.8. And this just does the math for us to make me subtract one less number. Thank you, Internet. There we go. So he went down 11.1 feet. So here's what I'm going to do. I'm going to grab a calculator. Right. How many feet per mile did he go down? And then we have a number to go with this hill. It's how steep the hill is, like with numbers, you know, valuable. So he went down 11.1 feet over 0.1 miles, means that he went down a hill slope that's 111 feet for every mile. Every mile, if the slope were exactly that, you would go down 111 feet. That's what we call the gradient, the steepness, really, of that hill. Okay. Now, if I just say that to you, I put my, I don't know, what was he, 5 at the time? I put my 5-year-old son on a road that has a gradient of 111 feet per mile. Would you like really be able to visualize what that's like, what that means to say whether I'm a good dad or a bad dad? You can't really. That's not easy to do. Let's compare it just for giggles to a ski slope. I grew up skiing at Labrador, if we can find it here. I'm gonna have to go back to roads for a minute. Bearing with me, I appreciate it. Yep, right here. All right, I grew up skiing here. Let's do, this is Labrador Mountain, if you've ever skied there. If we were to do the gradient here, I'd be willing to bet it's a good deal steeper. So let's turn this on and just do the run of the chairlift. And if I remember, yeah, so it starts a little bit flat as you come off the chairlift, then you get to the steep part, then you get down here, right? So maybe at the get-go, you're like, well, I don't know, that doesn't look much steeper. Like this drawing doesn't look much different, but the elevation, the scale way over here is much, much, much different. So I think we're going to see. So I'm going to start right there. Over those 2/10 of a mile, no, 3/10 of a mile, for, so this is 1,485 feet per mile. A lot steeper mathematically. How many feet per mile does this go down? It goes way down. It's a Black Diamond ski slope. It's one of the harder ones they have there. Okay, that's going to be the task. Now the computer, we're not really going to use this as much as here. We got to be able to do this on pencil and paper, getting ready for what the Regents is going to have us do. But my job for you right now with this video, you're not going to have anything to actually do yet. This is just the intro. Your job would be to think about, turn this off. Your job would be to think about some of the maps maybe near where you live. I'm going to give you links to too, and I think I have this one already open. So this is the high school right about there. That's that road that goes down to Little Luke's. Come up into town, past Little Caesar's Pizza right there, across the bridge into the river. So what do you see here on this topographic map that's like you recognize that if there's things within Pulaski that you know, if you've walked down here along the river, what's the landform there along the river, and how do these topographic lines represent that? Okay, if you know an area here, again, I'll give you the link. There's 2 different maps. There's one, the town of Pulaski kind of sits on the border between this map, and then we'll look at this one too. Let it load slowly. This is they call it the Richland Quadrangle. If you live over on this side, are there some hills? Is there something that you can look at to say, okay, this hill that's by my house or this hill that's by my friend Steve's house, I kind of am familiar with that. I've moved around over there. What does it look like on a topographic map? And hopefully yours load faster than this. Mine were fast this morning. End of the school day, everybody's tired, including the internet. All right, so there we go. Because you can zoom in on it. So maybe you know somebody, there's town of Richland right there. Relatively flat, but if you go this way a bit, you get up into where there's some hills. Okay. How do I know that there's hills there? Maybe I've never been there because I've seen enough topographic maps where I know how to interpret them, and I know where that meant, what that would look like. I know over here it's a little bit flatter. The lines are further apart. You're not changing elevation very much. Okay. So those are going to be the 2 big jobs. Get a basic view of a local topographic map, at least one feature somewhere where there's a little valley, a little hill. What does that look like on this map? And think about what the idea of gradient is, mathematically how steep a hill is. And we'll be doing both of those and drawing some profiles and all kinds of fun stuff as we work our way through topographic maps. All right, thanks for sticking with me. Back to the survival guide for the next chunk of the lesson. Good luck, folks.